Hi all, back again in the workshop. Hope you're all keeping well and still out there model engineering and doing your thing. I'm just going to do a quick video and I'm going to break it down into bits because I'm actually going to show what I'm doing. So that's why this camera is a little bit low. It's just so I can grab things and waft them up into the camera. So if you've been following the Facebook page, which I hope you are, you'll see that I've taken delivery of quite a few laser cut parts. What I'm going to show you first of all, this is the the rear steps of the tender, the upright part, and you'll see there's 2 holes here and 3 holes up here. This is completely different to what's published on published drawings. This is as per full size. It's completely flat at the moment, and I'm going to bend this edge and this edge to give it some stiffness. Through this part here there's an actual support piece, and the support piece is bolted, 2 bolts on this, then there's a bit of tube and another back plate, excuse my nose from running, another back plate, and then there's 2 holes in that, and that marries up with 2 holes on where the guard iron's bolting. So that's what that bit is, why that's there. You'll notice there's no obviously treads there, and that's because they're here in flat format there. So I've got 4 of them. The 4th one is in the little jig that I'm going to show you now. The little jig is for putting the dimples in. Now you can see there's a wing sticking out here and a wing sticking out here. They're going to be bent upwards, so towards you basically. That's going to create the step uprights either side, and then obviously the dimples is going to be like it would have been on full size, so there'll be dimple plate pattern. This jig, funnily enough, it's very rusty because it got a little bit damp last winter. This jig was for my first class 2 that I was building with my dad. So long story short, he made a jig for doing dimple pattern steps. He's made 2 jigs actually, one for the rear steps and then one for the front steps of the tender, which are wider, so that's why there's 2 jigs. And all the little and then I've got a punch that I've left in the where the vise is. There's a punch, and what I'll do is I'll each one just give them a tap. It's only 1mm thick steel, so I'll only give them a little bit of a tap and it'll leave a dimple impression. So then when these are bent downwards, not upwards, if I bend them upwards, I've just thought about that as I was saying this, if I bend them upwards towards you, the treads, the dimples will be on the wrong side. So I need to get this very right and think about it carefully. Because I'm punching that way in, the dimple's going to be on this side of the tread. Bend that upwards, then the tread sides are in the right way, if that makes sense. You're going to see this now because I'm going to put this in the vise. I'm going to give it a bit of a whacking. And then I'm going to try and part these 2, and I say try because there's 2 pegs in the corners there, and the rust has got to them and made them quite tight, so it's quite tight to part the 2 plates. You can see there's 2 plates there. It's quite tight to part the 2 plates and get the step out, and especially once I've bent those up, because once they're bent I've got to physically part the 2 halves. So we'll get on with that now and you'll see exactly what I mean. All make sense? Probably not, but it'll make sense once I part the 2. Alright. Right, I'm hoping you can see this part now. So here's the little dimple maker, as it were, a little punch that's been turned, and it fits in there perfectly. Okay, so what I'm going to do now, excuse the mess around me. As I said in previous videos, I don't keep a particularly tidy workshop. Medium size hammer. I don't even know how heavy this hammer is. Again, it's a bit of an old one that's been 6-ounce hammer, this one. So start on the first one. And you hear the sound change as I hit it. That means it's put a good dimple and the shoulder's gone up. There. I'm just going to whiz along. Get all these done. Now I'm taking it at the minute at face value that this has not punched all the way through and broken the steel. It shouldn't have, because the steel should have enough deflection in it to create the dimple without splitting. And give us a good dimple without too much hassle. Because I'm going up to the shoulder on the punch, on that shoulder, it's not going too far through the steel. And the other plate, when I take these apart, I'll show you. The other plate has got a little hollow that the steel will go into as I punch it through. So it doesn't take long to get these in. It's not shaking too much, you can still see what I'm doing. I paused on that one because it didn't make the right sound before I took it away. I took the hammer away. Last row. This is a quick job between all my normal day jobs. Get out for an hour, make a dimple step, and that's it. So that's all of them dimpled. I'm just checking to make sure I haven't missed any. I don't think I have. So all I'm going to do now is I'm just going to bend these over, and I'm going to do it in a quite crude way, which is tapping it with this hammer. And the reason for that is I want it to look like it's been kind of forged up. Trap it like that. I want it to look like it's been made in a metal foundry, as opposed to pristine condition put through a press, which I haven't got. That's moving about too much for my liking. Let's see if I can trap it in a different spot. That's it. That's a better sound. Bent it up away from me so that the dimples will be in the correct position on the other side. Like so. So both sides are done the same, nice and square cornered. So I'm just going to pause you again, go back in the other workshop part and part these two. Alright, okay, we're back. Got the two parted, no problem. So that's the top plate, as you can see, hole straight through it. Yeah. Bottom plate, little dimple impressions there. And there we are, one dimple step. Easy as that. That's the underside, that's what you saw me whacking at with the punch, and that's what's going to be on show. So they've come out really well. Only 3 more of those to do. So what that'll do, just offer this up now. So what that'll do, so you've got the back part. Obviously I've still got to flange the 2 ends of that. That'll go in there and be soldered in. Yeah. See that? And it'll give a nice impression of a dimple step. Like full size, which is what we want. So I'm right pleased with that. I know what you're thinking as well. Why didn't you put a tab and slot on that to solder the 2 together? And the reason I didn't is, in a nutshell, I forgot. But it's no hardship, because it's not going to take a lot of heat for the solder to run between those 2. So I'll be able to prop them up in said position, It won't be there, it'll be about there. And we hold them, prop them up in the right position with a bit of flux on. Touch in a bit of fine 0.75 solder, silver solder, and it'll be done. Simple as that, because at the end of the day it's only 1mm thick steel. It's not like I'm going to stand on them to get on it, so they don't need to be any more than that. So what I might do is, I've just done one, I might bugger off and do the others, and then we'll have them all done together. As I say, it's a bit of a short but sweet video. Just quickly before you go though, show you some other bits that have come through from the laser cutters. There's these two parts. This is a cross piece. The cross supports there, they'll be bolted in to the two upper stretchers either end of either side, and that'll give a lot of strength in the frame to stop them twisting. Full size had those in them as well. And then the upper stretchers themselves are all here. They've only just come through from Edit Model Engineers Laser for me, so they're all here still in the bag, because I've got a bit of filing and that to do on them. I am trying to, with the front drag box as well, I'm trying to find a local TIG welder that wouldn't mind just nipping them up for me, just tabbing the, welding the tabs together for me, so that I can get, if I can get them all tabbed together, I can then kind of run them with a bit of solder. But I'm still in two minds how I'm going to do that, because if they're tabbed, how do I get the flux down the gaps and stuff like that for the solder to run in to finish it off? So I'm still in two minds about that. I might just clamp them all together and do it how I did all the others, how I did the rear one, and just put a load of clamps around it to sort it all out. But again, I don't know, I'm not too sure. If there's anyone out there that can give me some suggestions on that for that front drag box, there's a lot of steel in it, there's a lot of intricate parts to go in it, there's going to be a certain way that it's going to have to go together, so it's not like I can do it in stages and kind of do a bit, plonk them together, do a bit more, and then plonk another bit together. It's kind of all got to be built up and then done, and I don't know if I've got sufficient heat here to do it all. I'm not sure. So if there's anyone out there watching these videos with keen interest and has got a bit of experience with that type of thing, about TIG welding something and then soldering it afterwards, if you want to get in contact with me either on YouTube or on Facebook or whatever, just send me a message and say, oh, attack it this way, or I find attacking it this way works better. That'd be greatly appreciated. So thank you ever so much for watching. I know it's only a short video, but I'm sorry I'm fiddling with this when I should be talking to you. But yeah, thanks for watching and tuning in. I've had some great feedback from the last video, so keep them coming, and I'll try and keep the videos coming for you all. Thanks very much. Bye bye.